So this is the concluding lecture for the course Environmental Fluid Mechanics, which we have done over the course of 8 weeks. In this course, we tried to see different kind of flows. So we first started with the basics of the course, where we discussed what is, let's say, a buoyancy driven flow, what is stratification, what are the governing equations that we use, etc. Right? And then we saw two different class of flows, the vertical flows and horizontal flows. So in vertical flows, we considered plumes in convection, where plumes were obviously generated from different concentration between the source fluid and the ambient fluid, whereas convection, which we did towards the later part of the course, was assumed to be generated because of temperature difference. Right? So these two flows are mostly in vertical direction, where plumes are more related to the environmental pollution, where you get some contaminants getting released into the atmosphere, and we tried to study how these contaminants flow, what is the concentration of the contaminant at different locations, what is its volume, etc. And we tried to see it in very different conditions. When it came to the convection, there it is more related to the temperature profile of the convective boundary layer or convective layer. In simple terms, we try to predict the thickness layer, and that also actually affects the stratification that forms in the atmosphere. And at the same time, now you realize that stratification is actually important when we talk about contamination or pollution in the atmosphere. Right? So vertical flows were important in terms of contaminants flow and predicting the thickness layer as well as the stratification. And in case of horizontal flows, we studied gravity currents, surface water waves, internal gravity waves. And in case of gravity currents, we try to predict the velocity, the depth of the current, etc. Whereas in case of surface water waves, we studied instability and we performed instability analysis, and we tried to predict the amount of mixing between two fluids of different density and different velocity when there is a shear flow. Right? So that we particularly focus on horizontal flows, and that again in horizontal flows also we tried to find the rate of mixing between two fluids, or what is the depth of the gravity current, or this sort of behavior, what is the velocity, etc. Right? So here we did not really focus too much on the contaminant flow, but in general, when you talk about, let's say, mixing in clouds or mixing under the surface level in the sea, all these mixing behavior or mixing phenomena are part of environmental fluid mechanics, and we tried to see some basics of them. Right? And then vorticity dynamics is another topic that we studied, which, as we discussed, was not really related to the environmental fluid mechanics, but still we studied as a part of the course, and that is more related to geophysical fluid dynamics. However, you still understood the basics behind vorticity dynamics, how forced vortex and free vortex form. And in the end, we did porous media flows, where again we mainly focused on the mixing behavior of contaminants with background velocity, without background velocity, and then plumes in porous media which generates because of continuous leakage into the porous media from some source, right, of some contaminants. And then again, when you use the models that we derived, you can predict the concentration of contaminants at different locations, and also the volume of contaminants. Right? So this is overall the highlight of the course that we did, or kind of a quick summary of the course that we did. And what you must have realized was that we did a lot of mathematics, right? And that is the fluid mechanics. Actually, fluid mechanics is not possible without considering a lot of mathematics, because this is a physics course, physics of fluids. Basically, if you want to find some solution or result, you must consider a lot of mathematics, and that is what we have done. We use a lot of mathematical techniques to find solutions, where in some cases we apply dimensional analysis, some cases scaling analysis, in some cases we did potential energy balance with the kinetic energy balance, right? In some cases we use equation of a state, uh, all sort of things. And what I really hope is that now you must have got a flavor of what environmental fluid mechanics is, and you must realize that this is a very broad course. There are many different topics, and obviously if you want to consider every single thing in full detail, it is not possible. And that is why in this course we try to look at the basics of environmental fluid mechanics, so that gives you a good understanding of overall picture of different flows in this area. And now you should be able to extend this further. So if you read some journal papers from journals like environmental fluid mechanics, or journal of fluid mechanics, etc., you will find many different papers or literature which discuss these problems in detail. While we have focused more on the mathematical side of it, you will also be able to get many papers on experimental side as well as simulation side, and in field data. Based on field data measurements, people have performed many analysis. Okay, so I really hope that this course must have given you a flavor, and you should be able to extend this further very easily if you want to work in this area. And if you want to solve more realistic problem, then you will have to rely on more papers, because this course just gave you an initial idea. But initial idea is really important, because this gives you kind of an introductory idea of the field. And once you know the field, then obviously you can go deeper into the problems by going into more detail, uh, by either self study or working on some research problem, etc. So I hope you enjoyed this course over the duration of 8 weeks, and I really hope that you found it fruitful and you enjoyed it, and hopefully we will be able to get in touch in future regarding this course. And in the meantime, if you have any question while watching videos, lecture videos, feel free to get in touch with us. We will be very happy to answer your questions. All the best.